Hello. A lot of Samsung devices, such as smart TVs, smart watches, and smartphones, have this operating system called Tizen. I'm not sure how to pronounce it, but basically, this article talks about how this Israeli researcher found a lot of zero day vulnerabilities in that OS, and basically you can do remote code execution, which I'm not
Is
sure.
that? I don't think this is the right article. I don't think that's the right article. Yeah.
One second. I was reading it like 10, 20 minutes ago. So
You got distracted by the wholesome internet cafe.
Does the Wholesome Internet Cafe have wholesome memes?
I sure hope so.
Wholesome 1990s memes?
Right, I'll be reporting on it in Spartan.
Yeah, so basically, he found out that the OS uses stir copy instead of stir and copy, and there's no SSL encryption. So.
Yeah, this entire thing was kind of like super hilarious because they kind of just pieced together a whole bunch of their old code that they used on old, like super crappy phones. They're like, hey, we're going to make a new OS because screw you, Android. And they're pretty bad at their job.
Yeah, the guy who did all this said literally everything you could have done wrong, they did wrong.
I think the article said...
There's also a root exploit on their App Store a la the old Google Play double master key exploit. So, that's from Android 4.
I think the words on his post were, this is the worst code I have ever seen.
Yep. Yep, there it is.
It may be the worst code I've ever seen.
You can always find a job.
Samsung, they're obviously not hiring.
And for this article, it's a really long article, but it's pretty detailed. For like the first 70% of the article, they go through how broadband systems on a chip, SoC, how they can use that to do remote code execution. And basically, they also use TDLS, which is sorry, I don't know the acronym. Tunnel direct link setup to basically overwrite some of the flags which are shown here. And after they overwrite the flags, they basically make them set the timer so that they can put in their malicious code inside the timer and make their malicious code execute once the timer is up.
Thank you.
That's John. We'll talk about this real quick.
All right. I have some good news for you guys. So the printer we've been working with, so we ordered like 60 some hoodies, and they were like, if you want to print it on like the independent trading company hoodie, which is like a higher quality one, we wouldn't charge you anything more. And we think that's really cool. Only problem is that the independent trading company hoodie is like pretty much one size up from the Phillip hoodie. So I sent an email to everyone who actually paid and signed up for a hoodie, just asking for you to email me your size change. If you didn't get that, talk to me. If you want to change your size, email me and just say that we'll change it to whatever size. Okay, so IRSEC is coming up. We have almost 10 teams signed up. We have a few more spaces left, so you guys, it's not too late to sign up. So if you're interested, please do that soon. I don't want to have to tell you that we're full. Also, if you're a captain of a team, please talk to your team and find out the t-shirt size. I need that in by today so we can order it and have it what the deal is. Sign up links are there. And if you're not interested in blue teaming and you want to help you run a competition, sign up for the white team there. You get free food, you get to meet the sponsors, you get a t-shirt, and it's a lot of fun. Not a lot of sleep, but. Yeah, and also blue team packets came out this morning at like 7. So your captain should also forward you that. We have our first white team meeting this upcoming Saturday. So if you want to be on white team, sign up for Saturday. And let me know if you have any questions.
Alright.
Oh yeah,
So,
tomorrow.
so as you guys know, nominations for RC3 eBoard are open, so you guys can nominate yourself or another RC3 member that you think would be qualified to be the position. Just keep in mind, we're looking for people who are passionate, right? You don't have to be the smartest guy in the room. That's not what it's all about. It's about having a passion to learn security. If you want to learn that passion, you also want to help other people find that passion. That's who we're looking for. So if you're a guy who really wants to be passionate and help others find their passion in security, let us know and nominate yourself or someone else you think may know that. And then these slides, next couple of slides, have kind of outlined the roles and responsibilities for each position. So take a look at that if you're interested, or contact me if you have any questions. So B-Sides Rochester is Friday, April 21st, that's training day, and then Saturday, April 22nd will be actual B-Sides Rochester. That's happening here in this room, and then throughout Jesus the rest of the day. So it's $10 for the event if you can't afford it, or if you're having money trouble, just let someone on the e-board of RC3 Smart to know, and we'll pay for your ticket. No questions asked. There will be no RC3Club meeting on Friday, April 21st, so don't show up here because we won't be here because I'm doing a lot of training days and so are some other people. So we thought that we'd let you guys go to the training days rather than have club. So.
Boy, what's the time frame for these guys?
What, you mean the conference or the training day? Conference or training day?
Conference.
It's up on their site. It should just be like their main URL / schedule. But I think it's 9 to 5-ish. Go to the top. It says schedule, but it's in that weird font.
Alright, it starts at 8 a.m. So, alright. So, and then goes in. So, yeah. So, if you guys are interested in that, that's happening April 22nd. So, alright. And now we're going to move on to our presentation on networking and Cisco device security.
I see it's comfy. I'll come up for the part that I'm in.
Okay.
Hey, Ben, come here. Can you check and see if you have the stream? I have it running on my laptop. I don't think the stream is up. Because it doesn't show up here.
If you go to, did you log in?
I'm not logged in yet. Do I have to publish it or something? Also, the YouTube creds are not in the credentials document.
It's Gmail. Via the RC3Club Gmail account. And then you access YouTube with the Gmail account. Because YouTube
Okay.
is a Gmail product.
Gotcha.
Widescreen today, so. Okay, so this week's on networking, shaking hands, rubbing elbows, chicken babies. That's a pun. You'll get it later. It's fun. So, disclaimer, as we do every week, the stuff that you're learning is for educational purposes only. Don't do stupid things. Be good, be more. And just a special thanks to Ryan Whittier and Joe Graham. They made this week's demo, and they made a really awesome demo. So.
I need that verification code.
But her brace is not. Yeah, we should learn more. And our spring sponsors, we meet some of the
does say we're live.
So actually, a lot of them are coming out.
Why are we leaving now? Okay.
You know, network with them.
Do I have to publish it?
Okay, so what's a network? A network is basically any set of interconnecting lines that resemble a net, therefore a network. A computer network is a system of interconnected computers.
I think we need to edit it because it says like secure coding and stuff.
It's any network. Probably connected to the internet. So let's talk about your network.
It's just because it's last week's. Yeah, don't worry about it.
Don't worry about it? Okay.
So let's talk about like your network, your topology in general, right? Like,
Okay.
how do you secure your entire infrastructure? So some of the questions you might actually ask yourself are like number one, what is the rest of your infrastructure? I mean, the first thing you have to do is you have to understand the topology that you got. You have to see, okay, where are some entry points? What servers are public facing? And also, if you have internal applications, like a web application that might be your IRSec linking packet, what possible problems might arise with your web application? Number two is, well, how do you stop them from getting in? So there's using IDSs, IPSs, there's host-based firewalls, and there's router and switch configurations, or active control lists, and also other configurations for the server, for the device itself. And last but not least, how do you manage risk, right? There's total security, which is just keeping your device offline, which is, no one's gonna break in unless your physical security is an issue. And there's total accessibility, which means that everything's totally available. So when you're protecting your infrastructure, you really have to think about basically like find a compromise between the two. Minimize accessibility, but always make sure that whatever is accessible, but turn off protocol you don't need, stuff like that. So at the vanguard of your infrastructure are these gatekeepers. So the first line of defense is your router, and your router routes packets. That's how your information gets sent. Yeah, and your router is basically your gateway to send packets through your network. And things you would consider are just making sure it's patched, making sure protocols that you don't need are turned off, making sure that administrative access and privileges are set correctly, and other things like that you have like logging and intrusion detection. The second line of defense are firewalls. So these are kind of like your IDSs, IPSs, and you place it between the part where it's your network and the untrusted part of the network, which is like the internet, and you just, you keep it there so bad things don't get there. And the considerations are pretty similar. It's all like making sure that everything's patched, everything's updated, and you have the proper like intrusion detection and the proper firewall. And the third line of defense is your switch. So that forwards packets directly within your network. And a really cool thing about a switch is that you can segment off parts of it so that devices only stay on one network. So most of you guys have used Wireshark just for promiscuous mode. It's a way to segment the traffic so that devices on different parts of the segment can actually see what's going on the other. The considerations are pretty similar. Okay, so let's talk about how you go from right here to right there, right? You don't want to be the firewall all the way to the right because your thing's set up and you still get. Okay. I found that at 4 a.m. on like someone's Twitter. Yeah. So let's talk about what those two lightsaber guys look like, right? What does like a secure network look like? Some things are, for example, just having strong passwords everywhere, making sure that you don't have default passwords because if you have default passwords, admin, they're gonna get in. Making sure that your devices are all patched, making sure your devices are all updated, and making sure that if you're not using a protocol, there's no reason for you to keep it up, right? And something interesting is just like making sure that like ping traffic is always being screened, right? If there's like huge ICMP packet coming through, that's weird, and you might need to look at that. Other things are just that make sure that your traffic is being logged, ingress, egress. Just making sure that you understand the traffic that's within your network and also going through your network. Something really important to note about that is that making sure your devices are synchronized at the same time, or else you're going to be confused when you look at your logs. And change your default passwords. Please change your default passwords. Really serious. If there's anything you take away from this, change your default password. But otherwise, we'll talk about access control lists and SNMP, or Joe's going to talk about SNMP later. So let's get into the practical stuff. Cisco holds 70% of the market share for networking devices, although we'll see what Arista does in the future. But the Cisco iOS is the standard configuration system. It's a standard command line interface for all Cisco routers. And when you sit down on a router, I guess, what's the first thing you do? I don't know if you can see that well, but you do enable config T, and now you're in configuration mode. So once you're in configuration mode, you have a lot more options. So the first thing you can do is show run, and you basically see the entire router configuration file. Or you can do show privileges, which shows you the privileges of the administrators. And something you can do is that you can basically set a password for your administrator user. And there's a difference between enable password and enable secret password. The difference, I think, is pretty much that the enable password one is crackable and the secret one isn't. Yeah, okay, awesome. And that's a command to basically enable a password. So you're doing enable password level 2, choose the privilege level, and then your password, and then they'll do encryption. And then when you show run, it'll basically say that the administrator has a password at this level, and the password will be encrypted.
The enable secret isn't crackable, obviously, but like in comparison to the enable password, you can literally just look up on the internet, oh hey, how do I crack a Cisco enable password? And like the first result is a web app that can just decrypt the password, hint hint. So don't use it, it's trash. It should never have been used and implemented, but don't use it now.
Trust that. Okay, cool. So speaking of privilege, so the way Cisco iOS works is that there are 15 levels of privilege. So number 1 is the lowest amount of privilege. That's user exec mode. So that's like the very basic user level command. 15 is privilege exec mode. This is what your admin account should probably have, or else you can't do enough things. And don't let Reggie get to level 15, right? So change your default passwords. And I guess something to think about. I guess this is more like the system side, but like how do you determine the level, like the segregation of user accounts? So like a user account for any regular user should be level 1, and like that person shouldn't even have the ability to ping. But if you have like a tech support account, maybe do 1 and a ping, like tier 1 tech support, right? But then if you have like junior admin, like put them at a 5. And then if you have admin, if you're the admin, make sure you're 15. And so that's the command to do it. So it's privilege mode, and then your level, and then you can add an extra command. So like this one is privilege exec level 5 and ping. So that means the level 5 will have ping. Yeah. Okay. The next thing is access control list. That's what an ACL is.
Such good tips in this presentation.
Yeah. So that's what you want to do, right? That's what you want to do to red team. You just want to make sure things don't get through. And how you do that is you use an access control list. And those are rules that basically let you permit and deny any type of traffic. And the way you specify the type of traffic is you can do it through the protocol, the source address, the destination address, and the port number. And so we'll get into like the rules and guidelines of it, but essentially you have one list per protocol, per direction, per interface. And once you apply it, it starts working, which is really good because you don't have to restart anything. So some other rules and guidelines. So when you do an ACL, routers will apply these lists sequentially as you configure them, unless you give them a line number, and we'll get into that. And that packets will be processed until there's a match made with the ACL. So once it makes a match, it'll just, if you say deny, it'll deny, or if you say allow through. My screen is blank, so I can't see anything. Yeah, and at the very end of your ACLs, there's an implicit deny all, which is great, right? Because you want to, unless you specify for it to go through, you want to deny it. And the lines, just the guideline of making your ACLs, the lines that you think have the most potential matches should always be at the top. And yeah, and you, oh, wait, that's, should say it must be applied to interfaces. But so on a router, you have at least like 2 little holes that you plug your Ethernet things through, the interfaces. You want to apply those, you want to apply your firewall rules to like a specific interface to get them working. So let's talk about ingress and egress traffic. So an ACL is great because it can filter both ingress and egress. Inbound traffic must be checked against every rule before it can be allowed through. And having strong inbound rules can stop malicious traffic from getting into your network, but having strong outbound rules can stop unauthorized traffic from getting sent out of your network. So something like a beacon that's being sent from your computer to an attacker would be stopped by an egress filter. Right? So what's up?
If you're done, I was just gonna go side note on those.
What's up? Wait, what was the question?
So it's like a side note on ingress and egress. Like, this is an example of how important that sort of thing is. Like, I've had malware on my boxes before, and I've had the red team members tell me that the malware is on my box, but they're like, yes, it's not actually able to call back to us. So if it can't talk out of your box, it can't exfiltrate data, and it can't get commands. So it's very important to realize the difference.
Yeah, exactly. If you can't leave your network, you can't do anything. So essentially, raindrop packets. So let's go into what a standard ACL is. There are 2 types. There's a standard and then there's a extended one. So what you do is you do Accesslist and then you do the list number. So that's 1 to 99. And then you can permit or deny, and then you put the source address and you put the source wildcard back. I'll get into the wildcard in a second. Let's talk about extended ACL. So these are a lot more complicated, but the difference is that you can only block with source by source address here. You can block by a lot of different things. Like you can say that you want to block SSH traffic, and you can literally just type SSH and block it. And you follow this guideline. You have access list, and then you have list number. So the difference here is that the list number here starts at 100. This is important. Do that. Yeah, and then you permit and deny, and then you can specify the protocol, which would be IP, ICMP, TCP, UDP. Might be a few more. And yeah, so then you put your source address, you put your source wildcard mask, and then you put your port, destination IP, all that. So let's talk about what a wildcard is. A wildcard is basically how you kind of specify what you're blocking. So when you have 0.0.0.0 versus like 255, basically, so the way the wildcard works is that it's specifying which bits of that IP is blocked. So you would do like 192.168.10.0, and then with the wildcard mask, you would do 0.0.0.255, which means all 255 of those addresses in that subnet range are blocked.
It's effectively the inverse of the subnet mask. So you notice on the last slide, the class C subnet, the first 3 numbers were 000, and the last one was 255. That is obviously the inverse of the subnet mask for that type of network.
Reset. Yeah. Okay, I think you guys can see that. So you want to look at your access list, you show access list, see it'll say like your standard IP access list, and it denies that, but also permits any. You can also say show access list 1, which is, as we said, the line number before. And how you would add that access list to the interface is that, so once you're in enable, once you're in config mode, you do access list, and you set your access list, you have to go to your interface, and then you have to, that's the command, essentially, to apply it. And once you apply it, it starts working. And in this case, it's 9.172 something traffic, and then permitting any. Yeah, and if you want to view ACL of that interface, just do show IP interface. So that's 0.0. That's interface fast Ethernet 0/0. And if you want to remove it, you would do you would literally just put no in front of it. So you to apply UIP access dash group 1 out, and then to get rid of it, you just put a no in front of it. It's the same way. It's essentially no is how you undo anything or remove anything. But the problem with access lists is that they aren't exactly enough. They can only do so much. You have to let some traffic through, right? Like if you have a web app, you have to let HTTP traffic through. Yeah. Go ahead.
Joe.
Now, just like that.
Oh, wow. Yeah, this screen doesn't have anything on it. I totally understand. I'm like, why is Sean not just looking down? Like, oh, it doesn't have anything on it. All right, so I'm going to talk about Simple Network Management Protocol, which is complete trash, and I'm going to talk a little bit about Tickle, which is a script. So Simple Network Management Protocol was made to manage network devices simply. Unfortunately, the SNET acronym, like I have said, does not stand for security, which basically defines how they've written the protocol for the last like 10 years up until the most recent version. Basically the way it works is that you have a managing host that goes out to a bunch of agents and says, hey, let me see what your MIB is, which is a management information base, which is basically just a piece of information about something on the operating system. So you can have anything from the version of Windows that's running on there to every single like process and port number and stuff like that. So there are 3 versions. Version 1 was the absolute worst. There was basically no any sort of authentication, no reliability. It works based just on community strings, which is like a password that is sent over in clear text when someone tries to access your stuff. Version 2 implemented some more efficient ways of getting a lot of data. In version 1, you would just have to say, all right, give me the next MIB a bunch of times, which is stupid. In version 2, now you can do get bulk requests, and then also did manage more security stuff. They did like a party-based thing that was super complicated and nobody understood, so after a couple of years, they're like, all right, we'll just go back to community strings. Then they had version 3, which finally added support for authentication and basically anything good. If you're going to use SNMP, use SNMP v3, otherwise you're going to be super insecure. It supports usernames and passwords. It supports actually confirming like reliability of messages, so people can't just say, "Oh yeah, this is the next MIB," and it's not actually what the next MIB is. Yeah, you can secure this with ACLs as well. Not very, it's kind of dark, but basically what the ACL there is doing is it's denying 3 specific hosts, like a host, and then access from 2 different networks, but permitting anyone else to reach into, to be able to query the SNMP server, and then also applies a read-only community string in the public. It uses the first ACL and a private community string that can do read-write using the second ACL. Okay, Tickle. Tickle is a general purpose multi-paradigm system programming language. So think of Tickle as like before even Perl. It's a really, really old scripting language that hasn't been used in a long time, and I think the only thing that like, uses it in modern technology besides doing some GUI stuff in Python is Cisco. Basically, you can use it to manage any sort of scripts. People use it to run CLI commands continuously or on a time frame. And it was also mainly used so that you could use Simple Network Management Protocol. The Tickle shell can be enabled either manually by just going over to CLSH, or you can run it on like the Cron job. In order to enable Tickle, basically just do that to say, here's the location of a couple of scripts to initialize the script if you need that, and then you just go into Tickle shell and run whatever commands you do. You can also do Tickle shell and then the source of or the destination of a file to read in all the commands that you want to do, or that you want to. Yeah. Anyone got any questions? Okay. Down.
Can I use SNMP B2C on my digital network? I don't have to be worried about it, or do I have to use D3 everywhere all the time?
I mean, this is America, so you can do whatever you want, but I would advise you do SNMP v3 unless you're using like devices that don't support it. SNMP v2 is only marginally better than v1. It doesn't really have any security benefits, especially if you're using C, which is the version that goes back to using community streams. Because it still has the same problems that one does. It just is slightly more efficient in how you can request a bunch of information, which for a security group means it's basically useless as an version. So. Yep, V3 implements encryption for packets being sent out, which is part of the reason why you can assume that no one's injecting stuff into your packets unless they somehow got the key that's being used for encryption. So, anything else? Okay, let's go back.
So before we go upstairs and do the really awesome demo that Joe and Ryan prepared, for the people who've seen the bluetooth packet, does anyone have any questions about it that they can answer? No? Okay. Cool. Awesome. All right, we're just gonna watch this right now. Go back to the gym. This is my favorite gym. Thanks, guys.